So atomic mass unit. What is atomic mass unit? As we said, A and U. That is defined as 1/12 of the mass of carbon nucleus, and it is abbreviated as AMU and denoted by sometimes like U, right? So the value we get through that, it is, for example, 1 AMU, which is equal to 1/12 into mass of carbon 12 atom. So 1/12 into 1.99 into 10 power minus 26, right? So we'll get finally the value for that as 1.6 into 10 power minus 27. So we'll get the final value, that is 931 mega electron volt. Okay, so 1 AMU value. So this is the value for the atomic mass unit. And the next one is, what is nuclear force? The nuclear force, which is nothing but the force acting inside the nucleus or acting between the nucleons, which is called the nuclear force. So the nuclear force is usually that the strong attractive forces, right? It is acting between the protons and the neutrons, as we said, right, of the nucleus. And the important properties we can see. And before that, this is the strongest force in nature, and it is very short range of attractive force, and it is a non-central force, non-conservative force, and it is neither gravitational nor electrostatic between, right, the range, and it is independent of charge, and it is 100 times that the electrostatic force and 1038 times of the gravitational force. And as we know that the gravitational force is the weakest force among the different forces, like nuclear force, weak nuclear force, and electrostatic force in between that we can see. According to the Dikova, that nuclear force acts between the nucleons due to the continuous exchange of meson particles. Okay, right. So what is mass defect? The mass defect, which is nothing but the difference between the sum of masses of all nucleons, the sum of the nucleus, is called mass defect. So mass defect, as we can say, the difference of mass, that is mass of nucleus, which is equal to capital M, sum of masses of all nucleons, minus small m, masses of the nucleus, right? So we can get the value ZMP plus A minus ZMN minus Mn. This we can see later elaborately. The nuclear binding energy. So binding energy, which means what? First we must know. That means the energy which is required to break up the nucleus into its constitute the protons and the neutrons, and to separate them to such a large distance that they may not interact with each other. So that the binding energy, simply we can say surplus energy which the nucleons give up by the virtue of the attraction when become bound together to form a nucleus. So the expression you can get it, and the points which given, the mass of the nucleus, which is equal to the mass, the sum of masses of the proton and the neutron. See, through that example, to understand that better, the nuclear mass is always less than the sum actually. To understand this, see that 1680 has the 8 proton and the 8 neutron. Now mass of 8 neutrons, which is equal to what? 8 into 1.00866 U. And the proton, same like 8 into 1.00727 AMU. For the electron, 8 into 0.00055 U. So therefore expected mass for that, which is equal to 8 into 2.015, that will come for that 16. It will be get very little, right? So in simple word we can say that the mass of 1680, that nucleus is less than the value of the total mass of it constitutes by 0.13691 AMU. So this difference in mass of a nucleus and it constitute is called the mass defect. This only we are telling that mass defect, previous slide. So del M, which is equal to, we said that ZMP plus A minus Z into Mn minus M. By the time of doing the numericals, we can understand a more and more better way, right? And so what exactly does mass defect mean? The mass of an oxygen nucleus is less than the sum of masses of its proton and neutron, right? So therefore, the equivalent energy of the oxygen nucleus is less than the sum of the equivalent energies of its constituents. We can also say that if you want to break down an oxygen nucleus into 8 proton and 8 neutron leg, then you must provide extra energy for that, del mc square. So the relation between the energy EB to the mass defect del M is derived from Einstein's mass energy equivalence, that is equal to mc square, or EB here we have taken because binding energy we have taken del mc square, right?